Good morning everybody. As Dr. Rashid instructed us, today we will cover the fundamental theorem of calculus. We will discuss few examples and finally we will discuss the Riemann sum. The fundamental theorem of calculus is if a function f is continuous on the domain AB, so this is a function f and this is continuous on the domain AB, then this is the second fundamental theorem of calculus, and some book also said this is first fundamental and this is second fundamental theorem of calculus. So if you integrate f of x dx, then it would be capital F of b minus capital F of a, where this capital F is the antiderivative of small f. For example, if we integrate integration of from 0 to 4 to dx, then it becomes 2 integration of 0 to 4 dx, and 2 times integration of dx is just x, 0 to 4. So this x is capital F of x, okay, this x is capital F of x. So now we have to plug f of b, that means 4, minus f of a, that means 0, which is 8. Okay. And if we integrate a function f, then this integration geometrically represent area under the curve above the x-axis and between the limit. Okay, area under the curve above the x-axis and between the limit. For example, here we integrate 2 dx. So y equals to 2 is a straight line. So this straight line, and our lower limit is 0, upper limit is 4, and after simplifying we got 8. What does this 8 mean? This 8 means the area below the curve y equals to 2 above the x-axis and between the limit is 8. Okay, 8 square unit. If you count, so 1 2 3 4 5 6 7 8, we have 8 square unit. So in your homework you have some problem like this one. So here we have given the function f of x and we need to find area from 0 to 2. So we need to find area from 0 to 2, this part, okay, and it would be below the function, above the x-axis and between the limit. Now if you calculate, we have 1 2 3 and here another one, so total 4. So 4 is the answer, 4 square unit. And from area from 0 to 5, so if you calculate this whole part, it would be 10. Now if the graph is above the x-axis, then area is positive, and if the graph is below the x-axis, then area is negative. For example, here if you want to find area from 5 to 7, so this point is 5, this point is 7, so we want to find area of this part. Okay, we want to find area this part. So here we have 1 2 and this one, that one, it's around 1, so total 3. Since it is below the x-axis, so it would be negative 3, not positive 3. So if it is above the x-axis, the area is positive. If below the x-axis, area is negative. So this was the example of second fundamental theorem of calculus. And how about this one? So if g of x is integration of from a to x f of t dt, then g prime of x would be f of x. So we will replace this t by this x. But this function f of t should be continuous at x equals to a. For example, here we have g of x is this one. So here f of t is square root of 3 plus t square. So according to the theorem, g prime of x would be f of x. G prime of x would be f of x. So if f of t is this one, so f of x would be replace t by x, 3 plus x square. Okay. So again, this function should be continuous at x equals to 0. And when you put plug t equals to 0, then you got square root of 3. So this is continuous. Now for this one, f of t is e to the power 4 t square minus 4t. So g prime of x would be f of x. So replace this t by x, it becomes 4x square minus 4x. So this is the answer. Now we will discuss some properties of integral. So if c is a constant, then suppose you want to integrate 0 to 2 3 dx. So if c is constant, take it outside of the integral sign, 0 to 2 dx. So x 0 to 2, which becomes 3 times 2 minus 0, which is 6. Now if you have two functions f of x and g of x, and if you add them, then you can distribute the integral sign. For example, if you have 0 to 1, 2x plus x dx. Okay. So if I distribute the integral sign, it becomes 0 to 1 twice x dx plus 0 to 1 x dx. So if I integrate, then x square over 2, 0 to 1, x square over 2, 0 to 1. So this to that to cancel, plus 1 minus 0, 1 over 2, 1 minus 0. So it becomes 3 over 2. Now for this problem, even if we simplify first, so twice x plus x is 3x dx. So 3 times 0 to 1, 3 times 0 to 1 x dx. So if you integrate, it becomes x square over 2, 0 to 1. So 3 over 2, 1 square minus 0 square, which is 3 over 2. So the same answer. This one and that one are same answer. So you can distribute the integral sign. The result doesn't change. Similarly, if it is minus, the same. Now how about this one? Suppose you have a function like this. Now suppose this is lower limit a, this is upper limit b, and there is a point c here. Now if you integrate from a to c, from A to C, then you will get area of this part. And if you integrate C to B, you will get area of this part. So if you add them, then you will get area of the total part from A to B, from A to B. For example, here we have f of x which start from 0. So lower limit is 0, upper limit is 5. So this is 5, this is 1. So now from 0 to 5, the whole area is given as 15. Whole area is given as 15, and from 0 to 1, the area is given as 13. So this part area is 13. This part area is 13. So what would be area of this part? What would be area of this part? So if you apply formula, then from 0 to 5, f of x dx can be written as 0 to 1 f of x dx plus 1 to 5 f of x dx. So 0 to 5, its area is given 15, 0 to 1 it's 13, plus 1 to 5, we need to find this one. So 15 minus 13 is 2. So from 1 to 5, f of x dx is 2. So this part area would be 2. Even from the graph, it is clear that if the whole area is 15 and one part is 13, then other part would be 2. Now to integrate this one, we know integration of x to the power n dx is x to the n plus 1 over n plus 1 plus c. So this one we can rewrite as x to the power 1 half dx. So now n is 1 over 2. So if you integrate, it becomes x to the power 1 over 2 plus 1. Lower limit is 1, upper limit is 4. So x to the power 3 over 2, 1 to 4. So 2 over 3, 4 to the power 3 over 2 minus 1 to the power 3 over 2. So 4 to the power 3 over 2, if you take square root first, then it becomes 2, and 2 to the power 3 is 8. So 8 minus 1, which is 14 over 3. So this is the answer. Now for next one, we know if we take derivative of cosine theta, we normally get negative sine theta. So if we integrate sine theta, we will get negative cosine theta, because integration is the reverse process of differentiation. So integration of sine theta is negative cosine theta. Lower limit is pi over 6, upper limit pi. So negative, first plug cosine pi minus cosine pi over 6. So minus cosine pi is negative 1, and cosine pi over 6 is square root of 3 over 2. So it is 1 plus square root of 3 over 2. So this is the answer. Now to solve next problem, what we can do, we can multiply y minus 2 and 2y plus 1 first. So 0 to 3, if you multiply, it becomes y square plus y minus 4y minus 2 dy. Sorry, it is 2y square actually. 2y square plus y minus 4y minus 2. Yep. So it becomes 0 to 3, 2y square minus 3y minus 2 dy. So if we integrate, it becomes 2y cube over 3 minus 3 times y square over 2 minus 2y. So 0 to 3 and 2 over 3, 3 cube minus 0 minus 3 over 2, 3 square minus 0 minus 2, 3 minus 0. So 27, it becomes 9, 18 minus 27 over 2 minus 6, and it becomes 12 minus 27 over 2, which is negative 3 over 2. So this is the answer. Now to solve next problem, what we can do, from 2 to 4, we can rewrite this one as 4 over u cube plus u square over u cube du. So this one can be rewrite as from 2 to 4 u to the power negative 3 du plus 2 to 4 1 over u du. Now if you integrate, this one becomes negative 2 from 2 to 4, and integration of 1 over x is ln of x. So ln of u. Now negative 2 and 1 over 16 minus 1 over 4 plus ln of 4 minus ln of 2, and it becomes negative 2 1 negative 3 over 16 plus ln of 4 over 2, because we know ln of a over b is ln of a minus ln of b. So it becomes 3 over 8 plus ln of 2. So this is the answer. Now for the next problem, we need to identify what is wrong for this problem. So we have integration of negative 1 to 2 x to the power negative 5 d of x. So it can be written as 1 over x to the 5 dx. Now to apply the fundamental theorem of calculus, the condition was this function f of x should be continuous on the domain a to b. Okay, from a to b this function should be continuous. But here this function 1 over x to the 5 is not continuous from negative 1 to 2. Why? Because when x equals to 0, then 1 over x to the power 5, this function is undefined. So this function has a discontinuity at x equals to 0, so we cannot apply the first fundamental theorem of calculus or second fundamental theorem of calculus. So the problem is here f is not continuous on the domain interval negative 1 to 2, so this theorem cannot be applied. So So this is the answer. Now finally we will learn the Riemann sum. Riemann was a famous mathematician. So we have y equals to y equals to 3 over x, and we want to approximate the area of this shaded part. Okay, so luckily for this problem we can use the formula. So 2 to 5 y dx is from 2 to 5 3 over x dx. So if we integrate, it becomes ln of x 2 to 5. So 3 times ln of 5 minus ln of 2, which is 3 times ln of 2.5. So this is exact result, but we can use the Riemann sum and approximate the area. Because all of the function is not integrable, we cannot integrate all of the function, but using the Riemann sum we can approximate the area. Okay, so if we want to approximate the area, we think with n equals to 5, that means 5 subintervals. So we have from 2 to 5 3 over x dx. So our lower limit a is 2, upper limit b is 5, and number of subintervals would be 5. So what would be step size? Step size means length of this part, and this 5 means 5 subinterval. It means, did you see here we have 1 2 3 4 5, total 5 rectangle we have here. So step size would be b minus a over n, which is 5 minus 2 over 5, which is 3 over 5, and it is 0.6. So if the first point is 2, then this point would be 2 plus 0.6, which is 2.6. Next point, this one would be 2.6 plus 0.6, which is 3.2, and this one would be 3.8, and this one would be 4.2, and last one would be 4.2 plus 0.6, which is 5. So those are the subintervals. Now we have to apply the midpoint rule. So to apply the midpoint rule, what we will do, we will determine this midpoint. So how we can determine this midpoint? So if we add 2 and 2.6 and divide them by 2, so 4.6 over 2, which is 2.3. So this point is 2.3. Similarly, this point would be average of 2.6 and 3.2, and similarly other points. Now if we consider only this rectangle, so for a rectangle we know area is length time width. So for this rectangle, if length is 0.6, if length is 0.6, this part 0.6, and this width is 0.6, and this part would be f of 2.3, because f of 2.3 would be this area, sorry, this length. And if we multiply 0.6 and f of 2.3, then we will get area of this rectangle. Okay. And similarly, we will find area of other rectangle and add them together to get an approximate value. So del of x is 0.6. We find f of 2.3, then f of 2.9, f of 3.5, f of 4.7, and since f of x is 3 over x, so f of 2.3 would be 3 over 2.3. Now add them together and you will get the final answer. And if you compare your result, this approximate result and this exact result, they will be very close to each other. That's it for today's class. Have a good weekend. Bye.